So sometimes you have two triangles and you're trying to solve for an unknown like x. The first thing you need to do is understand if the triangles are in fact congruent. So you have to go back and you have to think, what type of triangle congruence do they have? Well, on this left triangle, all I see is an angle and a side. And on the right triangle, all I see is an angle and a side. So you have to know, is there any other information that is very obvious? Hopefully you remember that whenever two lines intersect, you automatically have vertical angles, and vertical angles are always congruent. So let's just understand the information that's given to us just by looking at the picture, just what is marked. We know that side AB is congruent to side DE because they both have one little mark. Now the first letter I chose was A because it has one curve on it. So over here I chose D instead of E first because it has one curve on it. That information is given just from the picture. It's given to us. Another piece of information that is given to us from the original picture is that angle A is congruent to angle D because they both have one little mark, so that's given. Okay. We also know that this angle BCA is congruent to angle ECD. Now that wasn't given to us at the very beginning. The reason why they're congruent is because they were vertical angles. Okay. So now I have two angles on one triangle and a side marked congruent to two angles and one side on another triangle. The question is that side in between the two angles? Yes or no? No, so I'm just going to put it at the end. Now let's practice naming the triangles. Triangle, let's just make it easy, ABC is congruent, and now we have to match up what it is congruent to. A had one marking on it, so I'm going to start with D because it has one marking on it. Then I went from A to B. That's the side with one little dash. So I'm going to go from D to E, the side with one little dash. And then my last letter is C. Okay. Now we need to understand, I'm solving for X. So I want to solve for this side BC. What is BC the same as? Well, it's really easy once you draw your triangle, write your triangle congruence statements. I know that BC were the second and third letter, so EC are going to be the second and third letter. So I can write BC is congruent to EC. And the reason here is not because they were marked congruent, because they clearly were not. They didn't have two little dash marks on them. The reason why they're congruent is because once we prove triangles are congruent, this step right here, once we prove that triangles are congruent, then we know corresponding parts of congruent triangles are congruent. That means the second two letters have to be congruent to the second two letters. Okay. Which is kind of tricky because if you just look at the picture, you might have accidentally said x squared minus x equals 5, but that's not true because we just stated that BC is congruent to EC. So the way you'd set up the equation is you'd say x squared minus x equals 6, and that's just by substitution. Oh man, x squared, we haven't dealt with x squared yet. So this is what we call solving a quadratic. It's called a quadratic because the variable is squared. Solving a quadratic, and we can solve it by factoring. The first step is you want to set it equal to 0. So you can't just say equals 0. You have to get rid of the 6. So how do we get something to the opposite side? We're going to do the opposite, and in this case, subtract 6. Now I can't combine anything because x squared and x are not like terms. And a variable and a constant are most definitely not like terms. So I have x squared minus x minus 6. To solve by factoring, and I'm just going to use some basic ones in this class. To solve by factoring, you're going to need to have your parentheses. And you think, what two numbers multiply to make the first term? Well, that should be pretty obvious. X times x multiplies to make x squared. They go in the front because they're the first term. Then you're going to think, what two numbers multiply to make the last term? And at this point, I'm going to ignore the negative, and I'm just going to look at this as a 6. So what two numbers multiply to make 6? Well, that could be 1 and 6, 6 and 1. Those are the same things. 2 and 3, 3 and 2. And we're going to focus on just sticking with whole numbers in this class. I'm not going to give you anything too difficult when it comes to factoring. So now that we have all of our combinations, we're going to think what multiplies to make the last term, that's 6, but adds to make that middle term. And that middle term, even though it doesn't have anything written there, it's really a negative 1x. So which numbers can I add together to make negative 1? Well, here, if I add a 1 and a 6, or subtract a 1 and a 6, I'm either going to get, when I add them, I'm going to get 7. When I subtract them, I'm going to get 5. Here, when I add them, I'm going to get 5. When I subtract them, I'm going to get 1. So which one looks closest to our middle term? Which one looks closest to negative 1x? That's right, the last one, the 2 and the 3. So I know I'm going to use my 2 and my 3. So how can I use a 2 and a 3 to get a negative 1? A plus 2 and a minus 3 will get us negative 1. Let's just double check everything again. What multiplies to make the last term? Does positive 2 and negative 3 multiply to make negative 6? Yes. And what adds to make the middle term? Does plus 2 minus 3 add to make negative 1? Yes. So this is called solving by factoring, but we haven't actually solved it yet. Once you've factored it, you're going to set each factor equal to 0. That's this 0 guy right here. And then you're going to solve them. Well, if x plus 2 equals 0, if I subtract 2, that means x equals negative 2. If x minus 3 equals 0, I'm going to add 3. That means x equals 3. Okay, let's just go back to our original problem really quick. Whenever you solve, you always want to check your answers to make sure that they make sense. So if x equals negative 2, if I plug it in, negative 2 squared minus negative 2. Let's simplify that. Negative 2 times negative 2 is 4. Minus a negative really means plus. 4 plus 2 is 6. Recall that we said BC was the same thing as EC. So 6 equals 6. Check. That works out. Now let's check our second answer. X equals 3. I'm going to plug it in. That's 3 squared minus 3. 3 squared is 9. 9 minus 3 is 6. Again, we said BC equals EC, so does 6 equal 6? Yep. So in this case, this problem, if I was solving it, I have two possible answers. X could either be negative 2 or x could be 3. And remember, x can be a negative as long as you plug it in and you get a positive length. And it makes sense that we have two answers because my degree is 2. My highest power is 2. That's telling you you could have up to 2 possible answers.